my dear students, welcome back to our own channel. Today we are going to calculate the packing efficiency of body-centered cubic unit cell. But first we will understand what is packing efficiency. So packing efficiency is the measure of how tightly the particles are arranged in any unit cell. Now, in earlier videos, we have already learned the type of unit cell. In body-centered unit cell, the particles are present at the corners as you can see over here, and there is one particle that is present at the center. Okay, and we have also derived how many number of atoms are present in this particular unit cell. So for BCC, the total number of atoms is 2. Now, in today's lecture, we are going to calculate the packing efficiency. So for that, we have the formula over here. Packing efficiency is equal to Z. It is nothing but the number of atoms that we have already derived. So for BCC, it is 2. And then into volume occupied by atoms. So my dear students, here the atoms are the spheres, right? And we know the volume of sphere is 4 by 3 pi r cube. So we have to find out the value of radius, and then there is the denominator volume of unit cell. Okay, my students, the formula for the volume is the side cube. Okay, for a cube over here, let us take this length. We will denote it as A, and the breadth and the height. So its volume will be side square, but we have denoted the side as A, so it will be A cube. So we'll put this value over here. Okay, so now we have to find the radius. So I'll just draw the cube once again to explain it in a better manner. So we'll take this cube over here. Okay, so now just focus on this particle. I'll draw it over here. It is such a huge particle. Okay, and then the particle at the center, I'm going to draw it. Okay, and then there is a particle over here, so it will look like this. Okay, and this is the radius of the sphere, and then this is diameter. We'll divide it, so it will become radius, and then this is the radius of this circle. Okay, and now we will just name this points. So it is A, B, C and D. Okay, so now you can see we have denoted these lengths as A. Over here also we will write A and this. Now just draw a line AC over here. Okay, so now what we have to do is we have to focus on this triangle, which is ACD. In ACD, the angle C is a 90-degree angle. We will apply Pythagoras theorem over here, this on this triangle ACD. Okay, so we know the Pythagoras theorem states that the hypotenuse square is equal to the base square plus height square. So the hypotenuse over here is AD square. So can I write it as AD square is equal to, this is AC square plus DC square. Now you can see over here that AD is nothing but there are 4 radius. So can I write 4r over here? And AC square, now we will consider one more triangle over here. This is also a right angle triangle ABC, and AC is the hypotenuse in this case. So the AC square will be equal to AB square plus BC square. Okay, and then the DC square is over here. So the square of 4 is 16. AB square, AB is nothing but A. So I'll write A over here, A square. And now we'll see BC is also A. So this is A square. And DC is also denoted as A. So A square. And now when we will sum all these A square, we'll get 3A square. Now we have to find the radius over here. So we'll shift the 16 over this side. And now I have to take the square root for finding out the radius. So root 3, and the square root of 16 is 4, and this is A. So now I have got the value of radius which I can put in this formula. Okay, so we will just write this formula. Packing efficiency is equal to Z. Students, for BCC the number of atoms, that is Z, is 2. So we will write 2 into volume. The formula of volume of a sphere is 4 by 3 pi r cube, and then there is 100 over here. The volume of unit cell we have already derived over here, it is A cube. Okay, so now we'll substitute the value of r over here. 2 into 4 by 3 into pi. The value of r is nothing but root 3 upon 4 into a, and we'll take the whole cube of this and then multiply it by 100, and then there is a cube in the denominator. So now when we'll cube this term, so we can cancel out a cube and a cube. Okay, so now we'll write this as packing efficiency is equal to 2 into 4 by 3. The value of pi is 3.14 into the cube of root is, you can see over here, root 3 into root 3 into root 3. So root will get cancelled. It will be 3 and then root 3. Okay. So we'll write 3 root 3 into 100 and we'll divide it by 4. So when you will, okay, there is a cube of 4 which is 64. Okay, so when we'll solve this whole sum, we'll get the answer as 68%. So this is the packing efficiency. Now we will find the empty space. So for finding the empty space, we will subtract the packing efficiency from 100. Okay, so 100 minus 68, we will get 32%. So now I hope it is clear to you now that the packing efficiency of body centered cubic unit cell is 68% and the empty space is 32%. Thank you.